Hi, today we're going to look at solving logarithmic equations. Sometimes when you have something that's not log 10 or not a natural log, it's not the easiest thing to solve. So what we end up doing is reordering the problem. And we're basically using this form, and we're taking our base, and if we move that, we can set up a new problem where we can say the base with an exponent of what that is equals x. So let's kind of reorder these things. I'm going to take that 3, I'm going to move it, I rewrite our problem. 3 with our new exponent, that's a 4. So I'm kind of like pushing that 3 over and under that 4. 3 to the 4th power, so 3 times 3 times 3 times 3, x equals 81. Okay, let's move this. So we got 36, move it over. We've got x equals 36 being raised to the 3/2 power. So now that we have an exponent that's a fraction, it's a little more complicated, but there's a couple ways we can do this. So we can look at this we can look at it using radicals. So I could do 36. That 2 is on the bottom. We can put the 2 on the bottom in the index. 3 is the top of the fraction. Put it up in the air. So what is the square root of 36? That's going to be 6. Bring down the exponent. X equals 216. Or I could rewrite 36 as 6 squared. All that's being raised to an exponent of 3 over 2, which I can turn this to a fraction. Now I have to multiply my fractions together and give us, let's see, 2 cancels out with 2, giving us that exponent of 3, which is still x equals 216. So either way works. Come up with the same answer. Now, what's going on here? So I have log base 13, log base 13. All I care about is that both of these are the same bases with that log. What that ends up doing, kind of like how we had an exponent and where we had exponential equations and the bases were the same, I can basically ignore them and create a whole new problem with just whatever's in parentheses. Now, the only reason why I'm allowed to do this is because they both say log base 13. Now, solve that equation like you would any other equation. Add 3x, subtract 1, and because there's a negative there, we got to divide everything by that negative, giving us -5. And that is solving logarithmic equations.